Batch Apex. All right, so Batch Apex. So here's one of our engineering change requests. On the first day of each month, run name and address cleansing routines on each candidate record. So before Batch Apex, you'd have to pull your data out using something like Data Loader, make modifications, and then push it back into Salesforce via an update call. With Batch Apex, we can create logic for doing something like this that runs up there on the Salesforce servers. Okay? So Batch Apex, it's an asynchronous execution framework that can operate on up to 50 million records. It is a very high volume mechanism, so you could go through your list of contacts or whatever in order to, over a long period of time, if we had 50 million, to perform some sort of conversion or cleansing or whatever to that data. A classic type of Batch Apex operation would be if you were going to introduce record types into an existing object that previously did not have record types enabled. Okay? So we could write the logic to query these records and then to modify them to set their record IDs based on data that we found within the records. Batch Apex can be run on a schedule using scheduled Apex or ad hoc. So we can just kick it off via a execute anonymous. How does Batch Apex work? Well, either via a schedule or via some sort of, whether it's via Visualforce controller or execute anonymous, it's going to be initiated. We're going to gather the records that need to be processed, and then what we're going to do is we're going to execute that business logic on an iterative basis. So we process in smaller chunks. What we end up doing is we break up, let's say we have 10 million records, we break it up into smaller chunks and then process those chunks of data. After it's all completed, we then execute some finalization logic. You might want to do something like send yourself an email saying my batch job is done, or update some record somewhere, some sort of indicator that you've successfully completed it. So to implement it, there is a batchable interface that we would need to create a class and then implement that interface. The way that we would execute it is either by explicitly doing a database.execute batch and then passing a reference to the class that we created, or you could create scheduled Apex and then schedule the batchable class that you created to execute. Within the batchable interface are three methods. There's the start method, which is all about collecting the records that you want to process. There's the execute, which is then going to perform the modifications that you'd like to make to those records. And then the finish, which is executed at the very end. Okay? So the batchable.start and the batchable.finish, those two methods only run once. The batchable.execute, in my case, if I have 10 million records, you're able to specify a scope size, but what you do is you take 10 million divided by the essentially the batch size that you would like to do, and then we process them according to that. When you kick off your Batch Apex job, you're going to identify the class that implements batchable. There's also this scope parameter, and what this does is this is one of the instances, or actually probably the only instance, where you can sort of explicitly control the size of your transaction beyond 200. Okay? So by default, this is going to be 200, but you can crank this up to 1,000. And so if you are doing something where you're not really concerned about governors, you can increase the size of your scope above 200 in order to process more records per each of these transactions. Okay? So you do have that capability to do that. So scheduled Apex, there is a schedulable interface. So to create schedulable Apex, you would need to implement it. And the idea here is that we define an execute method. Once again, this is another use case for our global access modifier. At the predetermined time, either you schedule this through the user interface, or you can actually programmatically schedule it within code here. So we could do something like use our, our cron tab type syntax to indicate when we want to fire this thing off. But the execute is, well, what do you want to do on whatever that moment in time is? A classic thing is to execute batch Apex, okay? Now the code that you execute does not have to be batch Apex, but it does have to be asynchronous. You do need to indicate that. You can monitor these batch jobs or asynchronous Apex. You get back this async Apex job. So here, when we're executing batch Apex, we get back this ID. We can then use this ID to do a lookup in the async Apex job. You guys have already seen this in doing asynchronous Apex when you went to set up monitoring Apex jobs. So it's a way to programmatically check things like the number of items that have been processed. Some people have done some cool stuff with JavaScript where, doing a progress bar. So creating a Visualforce page with a JavaScript progress bar where it queries, how many records have I processed versus how many are the total that are about to be processed. Key thing here, when you are testing batch Apex, first of all, only one iteration of the execute will ever be done, okay? So when it's executing batch Apex in the context of a test, even if you did something where you had 1 million records, it's only going to call that execute method once, okay? So we want to prevent someone from accidentally kicking off a super long test, okay? The other thing, this is a best practice, is that when you're creating your query, and let me jump back to here and explain. When you are creating your start method, the idea behind the query locator is that you define the SOQL query, which is going to locate the records that you want your batch job to operate on. Okay? Like we said before, it doesn't return all of these. The purpose of the query locator is to use a cursor to fetch on based on the size of your scope, separate transactions of these records. Now, because we're using a SOQL query to find the records that we want to operate on in our batch Apex, when you're creating a test, we recommend that you create a public string, which is the query that you want to execute. That way, when you're doing your test, you can set this string and say, here are the records that I want you to find. In other words, here are my mock records that I want you to process. Okay? So you'd create your mock data and then generate the query to find those mock records in the database. All right? And this essentially gives you the ability to override this query. Okay? The other important thing, whether it's asynchronous Apex or batch Apex, a fundamental problem would be if it's running sometime in the future, how can I verify that it actually did what it was supposed to do? When you use test.startTest and test.stopTest, test.stopTest has a very important implication on asynchronous and batch Apex. When it gets to, if you're testing either of those, when it gets to test.stopTest, it runs your asynchronous code synchronously. So it'll run it right there. Now, inside your test, now you can check to see that your batch job did what it was supposed to do, or your asynchronous Apex. Otherwise, if it was going to be running in some other transaction, the test would be over, and then we'd be like, oh, I don't know how it succeeded or failed. You can maintain state in a batch Apex job, and there is a stateful interface. Now, the way that this works is that any instance variables that you have, like you might want to do a counter or collect some aggregate data, something along those lines. When you're implementing stateful, those instance variables will be kept around and available across executions of the execute method. Static variables will not. So jumping back to here, the execute method is going to be called multiple times during the running of a batch job. And each call to execute is a separate transaction. Therefore, how do I share data? If I want to do the aggregate, I want to count up a subtotal or something like that. How do I count the subtotal if I do a GC at the end of every single call to execute? That's where we'd implement the stateful interface, and now our instance variables in that batchable class will be available across executions. The query locator allows us to select a bunch of records from the database in order to operate on those records, but what if my batch job, its purpose is to create, let's say I want to create 5,000 new records, okay? So I want to populate my database with these records that I'm going to, describe and generate. Well, in that case, you can't really query the database because you're creating new records, right? What you can do is there's this other option, which is to supply a class which implements iterable. And what iterable is all about, it's about returning an iterator, and inside the iterator class is a hasNext and a next method that you need to implement. So if you're going to generate, let's say I want to create 5,000 accounts in a batch job, what I would do is I would implement these interfaces so that the system, in breaking up the execute calls, can utilize your implementation of the hasNext to check to see are there more records to process, and then your implementation of the next to fetch the next record. So you'd create in your start method an object that would, ultimately inside of it have those 5,000 accounts. Okay? And now your batch job is going to insert those into the database.